Okay. Hello everyone, welcome back to my class. So today we'll be looking at another expansion and factorization pattern. So today we're going to be looking at the perfect squares pattern. So this pattern looks something like this. Okay. So whenever you come across an expansion pattern that looks like this, where they ask you to expand two numbers inside of a bracket, added or subtracted, all squared. So first we'll just see what this looks like when we use FOIL. So when something is squared, all that means is that we have two of that. So for this bracket, multiplied together. Okay. So I just have the a plus b all multiplied twice. So if we use FOIL on this, we see that we get a times a plus a times b plus a times b again, where the order does not matter, and then b times b. So I see I get a squared plus 2 lots of ab plus b squared. Okay, so I know that when I see expansions of this form, I know I'm going to be looking at answers that look like this. Okay, so we'll do a quick example just to make sense of this. So if I have x plus 3 all squared and I expand this, I'll just do this using my FOIL. So I'm going to have x plus 3 times x plus 3. So if I use FOIL on this again, I will have x times x plus 3 times x plus 3 times x plus 3 times 3. Simplifying this, I have x squared plus 2 lots of x times 3 plus 3 squared. Now, so I've written this out in a specific way this time. So I can see that I have an x squared, then I have a 2, then I have my x here, and then my 3 and my 3. So my 3 comes from the fact that we have the 3 up here, and then my x comes from the fact I have an x up here. So you can see that I'm always going to have this 2 here. That doesn't change. But all I'm doing is placing the x inside the first bracket and in the second term here, as well as my 3 appears here and here. Okay. Then if we just finish this off, all we have is just x squared plus 6x plus 9. Okay, just simplifying that all out. So to make sense of all this, so what we're expecting is to see our first number in our x plus 3 all squared bracket to be here at the front, so x squared. Then we always expect our second term to start with a multiplier of 2, and then 2 times our first number, then times our second number, plus our second number squared. Okay, so we're always going to expect that pattern. So do another quick example now. So now I'll do x plus 4 all squared. Okay. So just to make sense of this one's a little bit more complicated. So all we're expecting is we're expecting our number squared plus 2 times a number plus another number squared, where we have our x going in the first position and also multiplying in the middle term. Then we have our second number multiplying in the middle term as well, and being added at the end with a square. So if I just simplify this all out, I get x squared plus 2 times 4, so that is 8 times by x, and then a 4 squared, which is 16. Okay. So what happens now if I have a negative inside this bracket? So we saw that with our difference of two squares, when we had our x minus b, or x plus b, where the order of these can be interchangeable. Okay. We saw that we had to have a negative between the one set of numbers and a positive between the other. It didn't matter the order, but we needed to have one negative and one positive inside of these sets of brackets. But with the perfect squares, we can have a negative or a positive here. Okay, so we'll see the difference that we get when we use FOIL. So once again, using the same process, we'll see what we get. So if we use FOIL, we get a squared, take AB, take AB, plus B squared. Okay. So I get a squared take 2ab plus b squared. So we've got a difference here now that we've got a negative in our bracket with the perfect squares pattern. We get a negative in this first position here, which stems from the fact that we have two lots of this minus ab in our FOIL expansion. So we know when we see problems of this kind, so for example we have x take 5 all squared, we know that we're going to be looking for a new pattern. So we're going to expect to have a square number, take two lots of our first number and then our second number, plus our second number all squared. So once again we have our x at the front, so that goes in the first position and in the middle. Then we have our second number, which goes in the middle and on the end as well, all squared. Okay, so you notice the form looks the same. The only difference we have is this negative in the middle is found in front of the second term. Okay, so finishing this off, we have x squared, take 2 times 5, which is 10x, and 5 squared, which is 25. Okay. So now we'll be looking at factorizing. So that was all expanding. So we're going from a set of brackets to an expanded expression. So now we're going to do the opposite. So we're going to do factorizing. Okay. So we know with factorizing, we're looking at going from an expression where we have either a negative or a positive at the front of the second term, and the rest all the same. So we're going from an expression that looks like these to something that looks like this. Okay. So we have forward position being factorization this time, where previously we were going in this direction, which was expansion. Okay. Yep, so as an example, we're going to do x squared plus 12x plus 36. So we're going to factorize this. Okay, so where do we start? So for factorizing perfect squares, we need to identify our squared numbers on the ends, as well as our 2 times each number in the middle. So the way that we do these is we first see if the first number is a square. So we know that x squared is equal to x squared, so that one's nice and easy. What about 36? So really we're finding the square root of 36, which is 6 squared. So that's going well. Then all I do is see if this x and this 36 in the middle here will equal 12x. So that's our real check to see if this is perfect squares. So does 2 times x times 6 equal 12x? So then I can just work that out, which it does. Success. So we know that we can use the perfect squares factorization here. So once we've done that, we can go straight to putting our number in the first position, and then our number in the second position, all squared. Okay, so that's the first example. So we'll go through our second example now, which we will see what happens when we have a coefficient out the front of an x squared. So let's look at 4x squared plus 16x plus 16. So we follow the exact same process as last time. So all we do is we do our setup where we see if we have the first number squared plus 2 times the first number times the second number times the second number squared. So first of all, we see whether 4x squared is a squared number. So we can see that 4 is a squared number because 2 squared equals 4. And we know that x squared is a squared number because x squared equals x squared, which is nice and easy. What about 16? Well, we know that 4 squared equals 16, so we can fill that in. And all we need to do is check, use that in green, whether our sets of numbers satisfy this middle number here. So once again, we'll do our check to the side. So we have 2 times 2x times 4 is equal to 16x. So we have 2 times 2, which is 4, times 16, times 4 is equal to 16x, which is what we want. So that's good. So this tells me that this is perfect squares, and I have my first number out the front, plus, because that is a plus, that's why we have a plus there, times the second number, plus the second number. And that is the final answer. So now we'll do some examples where we have we have 2x plus 5 squared. So we want to expand this. And then we have x squared take 12x plus 36, and we want to factorize. So pause the video and come back in a moment after you've attempted these questions, and we'll go through the solutions. Okay, so now that you've practiced the question and you think you've got the answer, let's go through the same check process, or the same method. So when we expand, all we do is we square the first number. We do 2 times the first number times the second number plus the second number squared. So all I do is place my 2x in the first position and the middle term, then my second number in the middle term, and at the end all squared. Yep. So all I do is go through the arithmetic, and I get 4. 2 squared is equal to 4. Then 2 squared, x squared is equal to x squared. Plus 2 times 2 times 5. So that's 4 times 5, which is 20x. Plus 5 squared, which is 25. So that's it. That's all expanded. Now we get to the factorization step. So when we factorize this, we suspect that it's perfect squares because we have positive, negative, positive, and 36 and x are square numbers. So we just want to check whether this middle term follows the perfect square factorization pattern. Once again, we see whether we have x, so we know that x squared is equal to x squared, so I know the x goes in the middle position here, and I know that 6 squared is equal to 36, so I need to see whether minus 2x times 6 is equal to 12x. So we'll do a little check to the side. So minus 2x times 6 is equal to minus 12x. So we can see that minus 2 times 6 is equal to minus 12. And we also multiply by the x, which is equal to our middle term. So we know that this follows perfect squares pattern. So we can jump straight to final answer, where we have x in the first position and 6 in the second position. And that is the final answer. So that's it for today. Thank you all for watching, and I'll see you next time.